Okay, let's unpack this deep dive on radio-controlled vehicles. We're looking at, well, a bit of a paradox, aren't we? The most fun places to run your RC car.
Yeah, the beach, dusty trails.
They're also the places that seem actively hostile to the car itself.
Exactly, actively trying to destroy it. And our sources, they really dig into why that happens. It leads to what they call premature and catastrophic mechanical failure.
Right, so today it's kind of a forensic analysis.
Pretty much. We're focusing on the two big threats: grit, sand, and dust causing abrasion, and then wind causing aerodynamic instability, especially with vintage models.
Okay, let's start with the grit then, the physics of the grind. Why is sand so bad? It's not just like regular dirt, is it?
No, not at all. The key is its composition. Sand is mostly silica, and silica has a Mohs hardness rating of about 7.
Which is pretty hard.
Oh yeah. Compare that to aluminum, maybe a 2.75 on the same scale. So when sand gets trapped between parts, it doesn't just sit there, it gouges. It acts like, well, like sandpaper.
Okay, I see. And the first place that becomes a disaster zone is usually the drivetrain, right? The gearbox.
That's ground zero. Almost inevitable that some sand gets in there, and when it mixes with the grease,
It turns nasty.
instantly, that lubricant becomes this grinding paste. It just systematically eats away at the internal gears, the bevel gears, planetary gears, whatever's in there. Constant abrasion.
Makes sense. So gearbox is bad. But you mentioned bearings, too. Even the sealed ones aren't safe.
Yeah, sealed is optimistic in these conditions. Fine dust, especially, finds its way past those seals on wheel bearings, motor bearings.
And then?
Same problem, different scale. It grinds down the hardened steel balls, the races, they get rough, they heat up, eventually they seize.
And a seized bearing isn't just a seized bearing, is it? It causes other problems.
Oh, absolutely. It creates a huge amount of friction, extra load. That puts serious stress on the ESC, drains the battery faster.
Yeah.
It's a cascading failure.
Okay, something practical from the sources. They mentioned wheel vents. Tiny holes inside the wheel rim.
Right. On the inner circumference, people might not even notice them. But when the wheel's spinning fast, centrifugal force literally scoops sand and dust into the tire through those vents.
Ah, so the tire fills up with grit.
Exactly. And that collected mass throws the wheel completely out of balance, dynamically unbalanced. You get this violent shaking vibration.
Which can destroy the hub.
Easily. Wheel nuts come loose, axles get stressed, the whole assembly can just tear itself apart.
But there's a simple fix.
Yeah, thankfully. Just put a piece of strong tape, like duct tape or Gorilla Tape, over those inner vent holes before you run in sandy or dusty places. Simple. Effective.
Good tip. Okay, so that's the physical grinding. Let's shift gears, no pun intended, to the invisible enemy, wind.
Right, aerodynamics. It's a bigger deal for RC cars than people might think because they have such a low mass compared to their surface area.
So wind affects them more strongly.
Much more. You start feeling it, seeing instability at speeds as low as, say, 15, maybe 20 miles per hour. It doesn't take much.
And the sources flag something specific here. Gusty crosswinds. They called it aeroelastic instability. That sounds complex.
It is, and it's genuinely dangerous for the car. It's this dynamic feedback loop. A gust hits the side, makes the chassis roll slightly.
Okay.
That roll changes the angle the car presents to the wind, which can actually increase the aerodynamic force, pushing it sideways or making it roll more.
So it snowballs.
Exactly. It's a snowball effect. The car's own motion amplifies the wind's effect, leading to these sudden, violent oscillations or even just spinning out completely unpredictably.
Wow. So not just getting blown off course, but the physics actively making it worse.
Precisely. And think about jumps, too. When the car's airborne...
Or flat bottom.
Yeah, the chassis plate acts like a wing, an airfoil. If you hit the ramp into a headwind, it can cause this kiting or parachuting effect.
The nose pitches way up.
Way up, and then it comes down hard, slapping onto the flat chassis plate. Really destructive landing.
Ouch. Okay, this seems like a good point to talk about vintage models. You mentioned classic Tamiyas.
Yeah, things like the Frog, the Lunchbox... Lovely kits, but they have specific vulnerabilities here. The materials, for one.
Yeah.
Old ABS plastic isn't as tough as modern stuff, and it gets brittle over time with UV exposure.
And the designs themselves.
Often less sealed. Think about older gearbox designs, like maybe the TT02 chassis. Even though it's newer than some classics, it's known for gaps. Those gaps are just open doors for grit. Straight into the grease.
Turning it into that grinding paste again.
You got it. But the real kicker for vintage stuff is often restomodding.
Putting modern, powerful motors and batteries in them.
Exactly. High-power, brushless systems, LiPo batteries. They put out way, way more force and speed than those original components were ever designed for.
Orders of magnitude more stress.
Orders of magnitude. There was one case study mentioned, a vintage gearbox filled with this sort of metallic paste.
What was it?
It was literally the ground-up metal from the original gears. They just disintegrated after maybe an hour of running with a modern powerhouse system.
That's brutal. Okay, so these environments are hostile. We accept that.
Yeah.
What's the defense strategy, the strategic arsenal?
Well, it starts before you run. Think about your lubricants. In dusty, sandy conditions, wet lubes, oils, thick grease, they just attract dirt. They become dirt magnets.
So switch to dry lubes.
Yeah, things like graphite powder or PTFE sprays, they leave a dry, slick film that lubricates but doesn't hold on to the grit nearly as much, essential for exposed parts.
And after the run, cleaning must be key.
Absolutely critical. And the order matters. Start with dry decontamination, compressed air, stiff brushes, get all the loose, dry stuff off first.
Before any water or cleaners.
Yes, especially if you've been near salt water, which adds corrosion to the mix. Get the dry abrasives off before you turn them into a wet slurry that gets pushed deeper into things. And check your bearings. If one feels even slightly gritty or rough after cleaning,
Replace it. Don't wait.
replace it immediately. It's already damaged.
Okay. So pulling this all together, what does it mean for the enthusiast?
It means, well, you have to be diligent. Proper preparation, meticulous cleaning.
Yeah.
It's just the price of admission if you want to run these high-performance machines in challenging, fun places. It's applied engineering, really.
It really is. Which leaves us with a final, maybe slightly uncomfortable thought for everyone listening.
Yeah.
Think about your really prized vehicle. Maybe that mint condition, original Tamiya Sandscorcher, is the absolute joy of seeing it run on a real beach, worth the almost certainty of causing permanent, irreversible wear to parts you might not be able to replace.
That's the cost-benefit analysis, isn't it? Something to definitely mull over before your next bash session.